The central processing unit, commonly known as the CPU, is the most important part of a computer system. It is often called the brain of the computer because it performs all processing activities and controls the operations of the entire system. Every action taken by a computer, such as typing a document, opening an application, browsing the internet, or playing a game, is executed by the CPU. Without the CPU, a computer system cannot function. It receives instructions from software programs, processes them, and produces the required output. The efficiency and speed of a computer largely depend on the power and performance of its CPU. A central processing unit, CPU, also called a central processor, main processor, or just processor, is the primary processor in a given computer. Its electronic circuitry executes instructions of a computer program, such as arithmetic, logic, controlling, and input/output, I/O, operations. This role contrasts with that of external components, such as main memory and I/O circuitry, and specialized coprocessors such as graphics processing units, GPUs. The form, design, and implementation of CPUs have changed over time, but their fundamental operation remains almost unchanged. Principal components of a CPU include the Arithmetic Logic Unit, ALU, that performs arithmetic and logic operations, processor registers that supply operands to the ALU and store the results of ALU operations, and a control unit that orchestrates the fetching, from memory, decoding and execution, of instructions, by directing the coordinated operations of the ALU, registers, and other components. Modern CPUs devote a lot of semiconductor area to caches and instruction-level parallelism to increase performance, and to CPU modes to support operating systems and virtualization. Most modern CPUs are implemented on integrated circuit, IC, microprocessors, with one or more CPUs on a single IC chip. Microprocessor chips with multiple CPUs are called multi-core processors, MCPs. The individual physical CPUs, called processor cores, can also be multi-threaded to support CPU-level multithreading. An IC that contains a CPU may also contain memory, peripheral interfaces, and other components of a computer. Such integrated devices are variously called microcontrollers or systems on a chip, SoC. The CPU performs several essential functions that allow a computer to work properly. One of its main functions is fetching instructions from the main memory. These instructions are stored in the memory in a sequence, and the CPU retrieves them one by one. After fetching an instruction, the CPU decodes it. Decoding means understanding what operation needs to be performed, such as an arithmetic calculation, a logical comparison, or data transfer. Once the instruction is decoded, the CPU executes it. Execution involves performing calculations, making decisions, or moving data between different parts of the system. After execution, the CPU stores the result either in memory or sends it to an output device. Along with these tasks, the CPU also controls and coordinates the activities of all other hardware components, ensuring smooth communication between input devices, memory, storage, and output devices. The CPU is made up of three main components that work together to process data. The Arithmetic Logic Unit is responsible for performing all arithmetic operations such as addition, subtraction, multiplication, and division. It also handles logical operations like comparisons and decision-making using logical operators. The control unit directs the operations of the CPU by controlling the flow of data between the processor, memory, and input-output devices. It ensures that instructions are executed in the correct order and at the right time. Registers are small, high-speed memory units located inside the CPU. They temporarily store instructions, data, and intermediate results during processing, allowing faster access compared to main memory. There are different types of CPUs, and they can be classified in several ways. Based on the number of cores, CPUs may be single-core, dual-core, quad-core, or multi-core processors. A single-core CPU can handle one task at a time, while multi-core CPUs can perform multiple tasks simultaneously, improving multitasking and performance. Based on architecture, CPUs can be classified as 32-bit or 64-bit processors. A 64-bit CPU can process larger amounts of data and support more memory than a 32-bit CPU. CPUs can also be categorized based on their usage. Desktop CPUs are used in personal computers, mobile CPUs are used in smartphones and laptops, server CPUs are designed for handling heavy workloads in data centers, and embedded CPUs are used in appliances and machines like washing machines, automobiles, and industrial equipment. A CPU has several important qualities that determine its performance and efficiency. One of the most important qualities is speed, which is measured in gigahertz. Higher clock speed allows the CPU to execute more instructions per second. The number of cores is another important quality, as more cores enable better multitasking and improved performance in modern software applications. Cache memory is a small but very fast memory inside the CPU that stores frequently used data, reducing the time needed to access information from main memory. Power efficiency is also a key quality, especially for laptops and mobile devices, as it helps reduce heat generation and extend battery life. Compatibility with other hardware components and software, as well as reliability and stability during long periods of operation, are also important characteristics of a good CPU. The CPU is used in almost every modern electronic device. In personal computers, it is used for tasks such as word processing, internet browsing, gaming, programming, and multimedia applications. In mobile devices like smartphones and tablets, the CPU runs applications, processes multimedia content, and manages communication functions. In industrial environments, CPUs are used in automation systems, robotics, and manufacturing control systems to ensure precision and efficiency. In the medical field, CPUs play a vital role in operating equipment such as MRI scanners, patient monitoring systems, and diagnostic machines. In banking and business organizations, CPUs are used for processing transactions, managing large databases, and performing data analysis. Embedded CPUs are widely used in everyday devices such as smart televisions, microwave ovens, washing machines, traffic control systems, and automobiles. The CPU offers many advantages, including high-speed processing, accurate calculations, reliable performance, and the ability to handle multiple tasks efficiently. It ensures proper coordination of all computer operations and enables complex problem solving. However, the CPU also has some limitations. It cannot function without instructions from software, and its performance depends on supporting components such as memory and storage. CPUs also generate heat during operation and require cooling systems to prevent overheating. Additionally, their performance is limited by physical factors such as clock speed and architecture. In addition to general classification, CPUs are also identified by their models, which represent specific designs with defined performance levels and features. CPU models differ in speed, number of cores, cache size, power consumption, and intended usage. These models help users choose a processor based on their computing needs, whether for basic tasks, professional work, gaming, or enterprise-level applications. Over time, CPU models evolve with improvements in architecture, efficiency, and processing power. One of the most well-known CPU manufacturers in the world is Intel. Intel produces a wide range of processors for personal computers, laptops, servers, and embedded systems. Popular Intel CPU models include the Intel Core series such as Core i3, Core i5, Core i7, and Core i9. These processors are widely used in desktop and laptop computers for everyday computing, professional work, and high-performance tasks. Intel also manufactures Pentium and Celeron processors, which are designed for basic computing needs, as well as Xeon processors, which are used in servers and workstations due to their reliability and ability to handle heavy workloads. Another major CPU manufacturer is Advanced Micro Devices, commonly known as AMD. AMD processors are known for offering high performance at competitive prices. Popular AMD CPU models include the Ryzen series, such as Ryzen 3, Ryzen 5, Ryzen 7, and Ryzen 9. These processors are used in desktops and laptops and are especially popular for gaming and multitasking. AMD also produces Threadripper processors, which are designed for high-end workstations and professional applications, and EPYC processors, which are used in servers and data centers for large-scale computing tasks. In the mobile and embedded computing market, ARM-based processors play a very important role. ARM processors are designed by ARM Holdings and are manufactured by various companies under license. These processors are widely used in smartphones, tablets, and low-power devices due to their energy efficiency. Popular ARM-based CPU models include Apple's A-series and M-series processors, Qualcomm Snapdragon processors, and Samsung Exynos processors. These CPUs are optimized for mobile computing and are capable of delivering high performance while consuming less power, making them ideal for portable devices. Apple is also a significant CPU manufacturer, especially after introducing its own custom-designed processors. Apple's M-series processors, such as the M1, M2, and later versions, are used in MacBooks and desktop Macs. These CPUs are based on ARM architecture and integrate multiple components such as CPU, GPU, and memory into a single system on chip. Apple processors are known for their high performance, power efficiency, and smooth integration with Mac OS. Other notable CPU manufacturers include IBM, which produces power processors used in servers and enterprise systems, and MediaTek, which manufactures processors for smartphones and embedded devices. Samsung also produces CPUs for its electronic devices, especially in the mobile segment. These manufacturers contribute to the diversity of CPUs available for different computing environments and applications. Modern CPU models have advanced qualities that improve system performance. Many CPUs now support multi-threading, which allows a single core to handle multiple instruction streams simultaneously. They also include advanced cache hierarchies and built-in security features to protect data and prevent unauthorized access. Improved fabrication technologies have enabled manufacturers to produce smaller, faster, and more energy-efficient CPUs. These improvements have expanded the range of applications in which CPUs can be used, from everyday household devices to advanced scientific research. The uses of modern CPUs continue to grow with technological advancement. CPUs are essential in cloud computing, where they process vast amounts of data across servers worldwide. They are used in artificial intelligence and machine learning systems to perform complex calculations and data analysis. In education, CPUs power computers and digital learning tools that support online classes and research. In transportation, CPUs are used in vehicle control systems, navigation, and safety mechanisms. In communication systems, CPUs manage data transmission, networking, and signal processing. The working of the CPU follows a systematic process that allows a computer to perform tasks accurately and efficiently. This process is commonly known as the instruction cycle. The CPU begins its operation by receiving instructions from a program stored in the main memory. These instructions tell the CPU what actions to perform, such as calculations, comparisons, or data transfers. The entire working process is continuous and repeats itself as long as the computer is powered on. First, the CPU fetches an instruction from the main memory. The address of the next instruction to be fetched is stored in a special register called the program counter. The instruction is transferred from memory to the CPU and temporarily stored in the instruction register. This step ensures that the CPU knows exactly which operation must be performed next. After fetching the instruction, the CPU decodes it. During decoding, the control unit interprets the instruction and determines the type of operation required. It identifies which data is needed, where that data is located, and which part of the CPU will carry out the operation. This step is important because the CPU must clearly understand the instruction before it can execute it. Once the instruction is decoded, the CPU executes it. The execution is carried out mainly by the Arithmetic Logic Unit. If the instruction involves arithmetic operations such as addition or subtraction, the ALU performs the calculation. If the instruction involves logical operations or comparisons, the ALU processes those as well. During execution, data may be moved between registers, memory, and other components as required. After execution, the CPU stores the result. The result may be stored in a register for immediate use, written back to the main memory, or sent to an output device. Once this step is completed, the program counter is updated to point to the next instruction, and the CPU repeats the cycle. This continuous cycle of fetching, decoding, executing, and storing allows the computer to perform complex tasks at very high speed. The CPU also works by coordinating with other components of the computer system. It communicates with input devices to receive data and with output devices to display results. The control unit ensures proper timing and synchronization between all components so that data flows smoothly and efficiently. Clock signals generated by the system clock regulate the speed at which the CPU performs each step, ensuring accurate and orderly processing. In modern computers, the working of the CPU is further enhanced by advanced technologies such as multi-core processing and parallel execution. Multiple cores allow the CPU to handle several instruction cycles at the same time, improving overall performance. Cache memory helps speed up the working process by storing frequently used instructions and data close to the CPU, reducing the time needed to access main memory. The CPU works as the brain of a computer, executing instructions and controlling all activities in the system. Its operation follows a continuous process called the instruction cycle, which includes fetching, decoding, executing, and storing instructions. First, the CPU fetches instructions from the main memory, guided by the program counter, which tells it where to find the next instruction. The instruction is temporarily stored in the instruction register while the control unit decodes it. Decoding involves understanding what operation needs to be performed and determining which data and CPU components are required. After decoding, the Arithmetic Logic Unit performs the necessary calculations or logical operations. Once executed, the result is stored either in a register for further use, written back to memory, or sent to an output device. The program counter is then updated to point to the next instruction, and the cycle repeats continuously. The CPU coordinates with memory, input, and output devices, ensuring that data moves efficiently throughout the system, and the system clock regulates the speed of all these operations. Modern CPUs also use multiple cores and cache memory to process multiple tasks simultaneously and access frequently used data faster, increasing overall performance. To keep a CPU working efficiently and extend its lifespan, several measures should be followed. Proper cooling is essential because excessive heat can damage the CPU or slow it down. Using a good quality heatsink, fan, or liquid cooling system helps maintain an optimal temperature. Regular cleaning of the computer interior prevents dust accumulation, which can block airflow and increase heat. Ensuring that the computer is used in a well-ventilated area also helps reduce overheating. Avoiding power fluctuations by using a surge protector or an uninterruptible power supply protects the CPU from electrical damage. Updating the system software, including the BIOS and drivers, ensures the CPU works with the latest instructions and optimizations. Limiting heavy workloads for prolonged periods and closing unnecessary programs can prevent the CPU from overworking. Finally, careful handling of the computer and avoiding physical shocks help prevent internal damage to the CPU and other components. In summary, the CPU functions by continuously executing the instruction cycle and coordinating with other hardware to perform tasks quickly and accurately. Keeping the CPU in good condition requires attention to cooling, cleanliness, power protection, software updates, and careful usage. By following these practices, the CPU can deliver reliable performance and remain functional for many years. In conclusion, the CPU works by continuously following the instruction cycle of fetching, decoding, executing, and storing instructions. This organized process enables the computer to perform tasks quickly, accurately, and efficiently. The coordination between the CPU, memory, and other hardware components ensures smooth functioning of the entire computer system. The development of CPU models and the contributions of various manufacturers have greatly influenced the progress of computing technology. Different CPU models are designed to meet the needs of different users, ranging from basic home users to large organizations and research institutions. Manufacturers such as Intel, AMD, ARM, Apple, and others continue to innovate, making CPUs faster, smarter, and more efficient. The CPU remains the most vital component of any computing system, driving technological growth and shaping the modern digital world. The central processing unit is the heart of a computer system. It performs all major processing tasks and controls the functioning of every component in the system. With continuous advancements in technology, CPUs have become faster, more powerful, and more energy efficient. Understanding the functions, types, qualities, and uses of the CPU helps us appreciate how computers and electronic devices operate in our daily lives. Thank you for watching this video.